sedimentation is over. Then the osmotic pressure. This method is based on Van Hoff's law, that is P equals to RTC divided by M, where osmotic pressure is denoted by P, which depends on molar concentration of the solute, that is C. T is the absolute temperature, M is the molecular weight, and R is the molar gas constant. This equation is valid for a very dilute solution in which the molecules do not interact manually. Next is Donan membrane effect. Diffusion of small ions through a membrane will be affected by the presence of a charged micromolecule that can't penetrate the membrane due to its size. Okay, its application is facilitating the absorption of ionizable drugs from a gastrointestinal tract by co-administration of macromolecules of same charge, so mutual ionic repulsion occurs. Co-administration of anionic macromolecules like sodium carboxymethyl cellulose with a diffusible anion like potassium benzyl penicillin to enhance the diffusion of the latter across body membranes. Next is viscosity. Viscosity means the resistance to flow. The resistance to flow of system under an applied pressure. Viscosity of colloids allows one calculation of molecular weight, and two, provide useful information about the shape of the colloidal particles. So, spherocolloidal dispersion are of relatively low viscosity. On the other hand, the linear colloidal dispersion are of high viscosity. If linear colloidal particles coil up into spheres, the viscosity of the system falls due to changing the shape. Now comes to optical properties. So study of optical properties helps in obtaining information regarding the shape, size, structure, and molecular weight of colloids. The sources of light and the resolving power of optical system mainly determine the precision and usefulness of such information. Interaction of colloidal particles with the light is as follows. When a beam of light strikes a particle, it polarizes the atom and molecules in it and induces dipoles in these particles. These dipoles emit weaker light at a same wavelength as that of the incident light. The emitted light propagates in all directions. This phenomenon is called as light scattering. So larger particles scatter more light. Light interaction can also be explained by the concept of refractive index. The dis- dispersion medium is characterized by refractive index. By a refractive index, when a medium is crystal clear and uniform, light would pass without any deflection. When particles of different refractive indexes are present in the medium, the particles of light is scattered in a different direction. In other words, scattered light is observed when the refractive index of the particles is sufficiently different from that of the medium. Tyndall effect is observed due to the interaction of particles with light. When an intense narrow beam of light is passed through the depression of colloids, its path is visible due to scattered light. This scattered beam is called Tyndall beam. This beam is most visible when viewed against a back, dark background, perpendicular to its incident beam. So this is an Tyndall effect. Light is passed through this colloidal solution, and here the light scattering light out. The true solution do not scatter light and appear clear, but colloidal dispersion contain opaque particles that do scatter light and thus appear turbid. That is called Tyndall effect. When a beam of light passes through a colloidal sol, scattered light causes the sol to appear turbid. So, importance of light scattering measurements: estimate particle size and shape and interaction. This is called the Faraday-Tyndall effect. Then the microscopic method, the light microscope and ultra microscope. So, ultra microscope has been used to observe the Tyndall beam. In this microscope, the dispersed particles appears as a bright spot. Dissolved polymer molecules and highly solvated salt particles do not scatter enough light to become visible. So, principle is like that. A condenser produced a hollow cylinder of light, and it converges into a hollow concentration to focus on a sample. The sample is placed in the apex of the concentration where light intensity is high. After passing through the sample, the concentration of light diverges and passes outside in all directions. This scattered light is viewed at the right angles to the incident light. Some scattered light enters the objective of a microscope. The particles appear as a spot of light against the dark background. Ultramicroscope is used to study the electrophoresis of charged particles, which helps in determining zeta potential. So particles appear as spots of lights against the dark background of the microscope. This is a technique of microelectrophoresis for measuring the particles charge. The It gives the actual picture of the particles up to 5 angstrom, used to observe the size, shape, and structure of salts. And high energy electron beams are used here, have the greater resolving power. One disadvantage is only a dried sample can be examined, not give information on solvation. Next, the electrical properties. Electrical properties of interfaces and electrical double layer. So, electrical properties of interfaces is the most surface acquires the surface electric charge when brought to contact an aqueous medium. The principal charging mechanism is as follows, like ion dissolution, ionization, and ion absorption.